These are the notes. If you happen to miss class and we go over the word problems, I know some people had a field trip, so I want to make this. Um, so this is what a word problem looks like with linear inequalities. We're trying to set up some equations that will enclose our area, and so they're these mixed nuts questions that they like to do. Um, and so I'm going to walk you through the thinking here. So we have 75 pounds of cashews and 120 pounds of peanuts. These are to be mixed into 1 pound packages. Now, first thing you need to know is 1 pound equals 16 ounces. That's going to be important when we set this up because we can't have some equations in pounds and some in ounces. So there's two types of mixtures. There's a low grade mixture, so it's cheaper because cashews are more expensive than peanuts, and it has 4 ounces of cashews and 12 ounces of peanuts. And then there's a high grade mixture that has half cashews, half peanuts. So it's a more expensive. And so we have a system, and we know these two are going to be part of the system. Any of the word problems with quantities, this is always true. You can't have negative pounds of cashews and peanuts. Okay, so we need to figure out what variables to use. Okay, so what we know we have 75 pounds of cashews and 120 pounds of peanuts. So we can't use more than 75 pounds of cashews, and we can't use more than 125. So that's going to be less than or equal to. So what we will do, and it's important that you make a note of this and write it down, because there are going to be very similar questions to this. There's one on the homework assignment, and then there are others that we will do. X is your number of low grade. So this is the number of packages, not the weight. Number of the low grade, and Y is the number of the high grade. So to get our equations, we need to think about, well, what does a low grade package of peanuts have, or of nuts have? It has 4 ounces of cashews, 12 ounces of peanuts. So if you want to think about it this way, you have, this is the number of packages. So for every package of low grade mixture, we have 4 ounces of cashews. And for every high grade mixture, we have 8 ounces of cashews. So 4 ounces of in the low plus 8 ounces in the high. So this is kind of like your cashews. And that has to be less than or equal to the amount of cashews we have. And then in our peanuts equation, for the low grade mixture, we have X number of low grade mixtures. There's going to be 12 ounces of peanuts for every X mixture, plus there's going to be 8 ounces of cashews. And our peanuts have to be less than or equal to 120. So those are your two equations. I'm going to put them up in a neater form, different way to see it. So we have a system. It's going to be in the upper right quadrant, and then we're going to find where those things intersect. Now, when you're looking at this equation, you might notice here there's this 1200, and you're wondering where that came from. The other parts of the equation are the same as what I did. But the 1200 comes from, that's when I told you before how many ounces are in a pound. 1200 was 75 pounds of cashews, and there are 16 ounces in a pound. So 75 times 16, that's where this 1200 came from. And for peanuts, we have ounces of peanuts times packages. This is the 120 pounds of peanuts times 16 ounces in a package. So I think it's easier to convert your pounds into ounces than the other way around. It's easier to multiply than divide. So when we put that together, we get these two equations plus this in the upper right. So we're going to graph this because the numbers are so big, we don't want to have to pick a scale. We're going to graph it using Desmos. And so you're going to open the Desmos calculator and just enter these equations. You don't even have to solve for y. And you enter those equations, and you'll see where the shared part, the thing that's you might have to know to get less than or equal, you type in less than equal, and it will combine those into one. Okay, so when we graph it, you see all this shading. Well, we know that nothing out here can be part of our answer. Okay, and so we know it's everything this way from the y and this way from the x. So we're thinking it's right in here. And then I can trace my two lines. And so it's going to be this area right here. And this line, if you look, that one has the bigger y-intercept. So, and I mean, it's blue, but it's hard to tell with all those colors. So that's everything under that line. So you're looking for this enclosed area right here. Okay, another thing to pay attention to when we get to the next section, we'll want to note what these points are. And again, you can put your mouse on there with Desmos and find out those points, because at those points will be our answers to solving some of these problems, because they're either going to be the highest or the lowest of whatever we're trying to do. Okay, that little enclosed area. Anything in that area is a solution. Some of them are better than others. Okay, this one's got a lot of words. So we have all of this stuff. They're going to invest money. They're going to invest up to 50,000. So up to means no more than 50,000, based on their average returns for the past 5 years. So one of them gets 4.35% and one of them gets 5.25%. It says a minimum of 10,000 is to go into the Icon fund, and a maximum of 25,000 into the Frost dividend. So we want some kind of combination that we end up with $800 in deposits or in interest. And if you remember, interest, the interest we earn is the rate times the amount. So sometimes it's called principal times rate times time. But it's the rate times the amount. So they even tell you here what to let x equal. Let x equal amount in the Icon and let y equal amount in the Frost. So we know a couple things about the Icon. We have to spend more than 10,000 in the Icon, a minimum of 10,000, so greater than or equal to. So that's going to be one of your equations. And we have to spend a maximum of 25,000 in the Frost. So those are your boundaries. We know x has to be greater than 0 and y has to be greater than 0. So we have a couple more equations. So we have these two. We have these two. Up to 50,000 means our total it has to be less than 50,000. There's a choice. So we got all kinds of equations. So right now we're at 5. And then the last equation is the interest one. So 0.435x plus 0.525y is greater than or equal to 800. So we have to make at least $800. So that's a lot of equations again, but if you go to Desmos, you can put all of them in. A big system, but your calculator on the computer is pretty helpful. Okay, so when we look at this, let's outline our answer here, and it'll do that in a second. But here, where we know x and y have to be bigger than 0. And we also know these two, x has to be greater than 10,000. So that's this line. So everything to the right of that is where my solution is. Because x has to be at least 10,000, y has to be less than or equal to 25,000. So that's, let me get a different color. That's this line right here. So everything down. So our answer is in that crisscrossed area. And so then that's when these two graphs will show up and tell you what that answer is. Again, it would be a big mess if we had to graph this by hand. So you want to use technology. And so it says interpret the meaning of each corner point. So when I graph this, I graph it down here, but you can see the shape that was made by what I marked, right? So we have points all of these places, and you can click on Desmos to see where those are at. That's why it's important to kind of keep in mind your area. So it's this funky shape right in here. And so each of those points are basically the intersections of all these lines. So you know the different coordinates. The one that's not easy to see is that one right there. And the reason why is because we know that the y value is 0, but it's not easy to see what the x is. And I can't remember if on Desmos, if you click on it, it'll tell you what the x is. But you can find it by solving some of these equations up here. So like right here, if you put in 0 for y, you get 0.035x is greater than or equal to 800. So if you take 800 divided by 0.0435, that's where you get 18,390.8046. That's why they just rounded to 18,391. So you can solve that equation and find this point. This one is easy because it's on the x-axis. This one is easy because you can line up, you know what y is, and you can find x. It's a nice whole number. This one, the y coordinate is not as easy, but we know the x coordinate's 10,000. So again, on that same line, you can go here and plug in 10,000 for x. So 0.0435 times 10,000 plus 0.0525y equals 800. And that's because we know what x is. We know x is 10,000 there. So you can always go back to your equations and plug those in. You might be able to click on it on Desmos and get that actual number as well. The next section will not be anything different. It'll just be interpreting those things. And so right now we're not going to quite interpret all those, but those corner points, for now, what you know is that they're the intersections. And so when it says interpret, basically what that means is you can plug in the different values and find out what the average earnings are. So essentially they're plugging those values into our equation for interest. So they're plugging the different x and y values. And you notice if you put $50,000 in x, which is that's where it makes the most. Well, that should make sense, right? You're putting all that money in one thing. You say, well, that's where it makes the second most. If you put it half and half, you get the biggest amount. There are other factors that come into play if you're investing, because some of these would be riskier, and so some people might figure in even another factor. So the biggest one happens right here. That's what we'll be doing next. We'll be setting up the same kinds of equations, but then figuring out when it says find the critical points or the corner points on your day 2 assignment, that's what it's talking about. It's finding those coordinates. Okay, so here is an example of finding the coordinates. So if you graph the system, then you just find all the intersections. There's another nuts. Same kind of setup. So look back at your one problem and set up the other one the same way. Okay, so if you end up with, I'm just going to make some stuff up here. So if I have, let's say I have this as my shape. I just need to determine the coordinates of those corner points. And I can do that by setting the two equations equal to each other. I could do it by putting this in Desmos, don't even have to solve it, and finding those intersections, any of those. Those are the important coordinate points. So that should be enough for right now if you missed class and need especially the word problems.